Good evening, class. Today we're going to go ahead and do the last two sections of the semester. Section 9.1 is actually probably one of the easier ones that we've ever experienced. So what we have to do is remind ourselves something that we did at the very beginning of the semester. It had to deal with square roots, but we needed to know the perfect squares. Now, perfect squares are these numbers that you have on the squares right here. They're resulting from squaring a number. So here you had 1 square. So in other words, 1 times 1 would be 1. 2 square, 2 times 2 will be 4. 3 square, 3 times 3 will be 9. So on and so forth. So at the beginning of the semester, we made a list like this. So you should have that. You should have it behind your multiplication tables right there. And it shows you all your perfect squares. Now, how does this relate to square roots? Well, it's very easy. What we're doing here is trying to figure out what number did we have to square to get that inside number right there. Now remember, the outside right here is called your radical, and the part that is on the inside is called your radicand. All right, so once again, here we're trying to get the square root of 4. So in other words, what number did we have to square to get a 4? So you go back right here, and this will be the root. So all of these numbers right here, excluding that square part right there, are known as your roots or square roots, since that's where we got those numbers from. So simply enough, square root of 4 would just simply be 2. Do not put the radical. It'll just be the number 2. Now you may ask yourself, what if we have a negative? Well, it depends on the scenario that you have your negative in. If you're negative on the outside, that's fine. It's like saying you have a negative 1 right there. So you're still going to take the square root of 4, which is 2, and you're just going to tag along the negative. In other words, what you're saying is negative 1 times 2 will give you negative 2. So that would be your answer. So no problem if you have the negative on the outside. But what if you have the negative on the inside? Well, think about it. Could you ever have this scenario right here? If you were to square a negative, remember, if we were to square, let's say, negative 2 times negative 2, would that give us negative 4? And the answer to that would be no. So in other words, we cannot have this existing right here. So this will be called a not real number. In other words, we cannot have that scenario. Whenever you square a number, it has to be positive. So you can never have this in existence. Now keep in mind that if you move on to college algebra, you're going to be dealing with this a little bit later on. This is also going to be called an imaginary number. But for our purposes right here, we're just going to call it not a real number. All right, so we move on to the next one. Square root of 100. Where did it come from? Well, it came from squaring the what? The 10. All right, so once again, nothing difficult at all right here. It's just a matter of figuring out what number did you have to square to get to that one. All right, so once again, from our first section right there, those are pretty simple. Just remember the main ones here is when you have the negative on the outside and when you have the negative on the inside. That's the ones that you have to be concerned with. Well, if we take a look at the second row we start off with a decimal. So once again, what did we have to square to get 0.25? Well, we know the square root of 25 is 5. So the square root of 0.25 must be 0.5. Now square it. 0.5 times 0.5 will get you that 0.25. Once again, do not include the radical. That would be your answer for that. For letter F, we have another repeat. In this case, we have a negative on the outside, so go back to these two scenarios. If the negative is on the outside, that's okay. We take the square root of 121. 121, it comes from squaring the 11. So this will be 11, but since we have the negative 1 or the negative sign outside, this becomes negative 11. And that would be your answer for that. So far, so good? All right, the last two examples have to deal with fractions. How do we deal with fractions? Well, it depends. If you cannot divide the numerator by the denominator, you're going to have to split it apart and then take the square root of each one individually. Since we cannot divide 81 by 400, we're going to go ahead and take the square root of 81. And once again, where did 81 come from? Came from the 9. So you have 9. And our list didn't go up to 400, but if you were to make the list a little bit larger right there, square root of 400 is essentially 20 times 20. So the square root of 400 would be 20. And your answer would be 9 over 20. Now keep in mind that if once you get your answer, if you're able to reduce, reduce. In this case, we can't reduce those two, so we leave it as is. Let's try another one. So this one has a negative on the outside. So same scenario as before. It's okay if it has a negative on the outside. Your answer will be negative. But since we cannot divide 16 by 49, we're going to go ahead and split them. So it'll be square root of 16 over square root of 49. And once again, we tag along the negative sign. Square root of 16, that comes from the 4. And square root of 49, that comes from the 7. So your answer will be negative 4/7. All right, so this goes ahead and concludes part 1 of section 9.1. See you in a little bit in part 2.